How's it going? All right, remember where we left off here? We made this so we could have a screen pop up, and there we go. But then remember, it made our mouse go wonky. Yeah, look at that. And so, yeah. So what we're going to do about that, we're going to limit that to 60 frames per second. So, things work. We're going to do something about that later on. We're going to introduce delta time so that we can become independent of our frame rate. But what we want to do now is we want to see something on that screen and we want to be able to control it. So how are we going to do that? Well, the first thing we got to do is we need something to display. So we're going to have to introduce a graphic of some sort. And as you can see on the left here, we have images folder. And the one that we're going to be doing is our ship, which is this thing, which looks terrible. Well, it doesn't. I mean, somebody else made that. That's not mine. I borrowed it. I actually plan on replacing it with my own ship drawing later on, but until then, it's a placeholder. So we want to make that graphic an option, and I want to make it perfectly clear that we're just talking about the graphic. So let's go ahead and call it something. We're going to call this spaceship underscore surface. So I like to call everything that is going to be a surface a surf, because it's easy to remember. And now we're going to load the image in there. So we're going to do Pygame. That's a property of the Pygame image. It's already there for us. And we're going to load it. Wow, it's like it knows what we're doing. So now we have to put in parentheses. It's going to require a file name. Now, everything is relative from where the main file is, which is outside of the images folder. So we want to go into the images folder. And then our graphic is, I believe, ship.png. And so that will load our graphic in as a surface. But for something, what I read was that you want to convert it. And also, this is an alpha because it's a PNG with a alpha channel. So we want to convert alpha. And it's right there. And that is a method. So that is our graphic. And of course, everything still works. But how do we display that graphic? Now, that is a bit more difficult. So before we do anything, we need to create a class, which will be our ship. And that class will have everything in it that we need to display, interact, move the ship in everything that we do, even fire bullets from it. So let's go ahead and create our class. And it's called ship. And notice down here it says while, and it has this, and it says expected indent block. That's because we have nothing underneath the class here. So we really want to put something there for the time being. Oh. And that will now make the script executable, no errors or anything like that. If I take that out and then try to execute it, obviously we're going to get an error. Wow, yeah, well, actually shows it. Yeah, expected indent block off. Yeah, exactly what it told us. So there we go. Now that we have a simple class made, we're going to need to fill it with things. Now, when you're creating a class, it is mostly thought of as a blueprint to what you're going to build. So in the sense that you have a blueprint for like a house, and then you want to build a street of houses. And then so you have this blueprint which is unique in itself. and then you start building all of these houses with this blueprint. The thing about the houses is what makes them unique is where the door number, the family that lives in it, maybe the furniture they bring into it. That's kind of stretching the analogy, but that makes them unique. But they all come from the same blueprint, and that's what we're doing here. We're creating a blueprint for the ship, even though we're only going to have one ship. It's still best to make a blueprint for it. So once we make the blueprint, we're going to make it real. We're gonna instance it, which is also called instantiating. So to make an instance of, even though we're still just going to make one. And so when you make an instance of a blueprint, the first thing that's going to happen is you're going to initialize its state. So we need to make an initialize, which is also called a constructor, I believe. Don't quote me on anything. However, if I get things wrong, feel free to tell me. Drop it in the comments, whatever. Tell me I'm wrong. Like, I'm not going to learn by thinking I'm correct all the time. So when you make a constructor, use 2 underscores, and we're going to do init. There it is. And then that's going to create our initial conditions. Now I delete this. You can leave that. If you're going to use it, use it. You know, that's basically saying that this is going to be this type of file type, or this type of object type, or whatever. I never put them in my other methods, and so the init one is the only one that I have auto-generated like that by pressing tab. So it will be the only one with the arrow on it, and that kind of looks weird. So the next method I want to make will be what happens when we start doing things with the ship. Obviously, it's going to need to update, and like we're going to have 3 sections. We're going to have, I mean, you can have more. We're going to be adding like a move and other stuff. But basically, you want to initialize it with values, then you want to update those values, and then you want to draw it to the screen. And you kind of want to keep those separated because it gives you more flexibility. So we're going to create another method called update. And notice that we're using self. I could probably explain that badly right now. But self is... so if I was to create a variable here, like variable equals 1, and notice how it's grayed out because it's not used. Now, if I wanted to say variable, and I wanted to increase it by 1, it still shows that it's not used because these are different methods, and this is in the scope of this method, and this is in the scope of this method. And if I try to run this, well, we haven't instantiated it, have we? So we can do that later on, but I could probably demonstrate that then. But these would have to have self here. And now these are a common variable. So this will initialize it to 1, and this, every time this method is called, will increase it by 1. So, but that's what the self is. So now our last thing is draw. And this is when we're going to be putting graphic onto the screen. Now, obviously, we need self because we want things to be transferable between other things, like the other methods. But also, we want to reference the screen in which we're going to be printing to, or like showing the graphic on. So we need a variable for that. Now, just because this is called screen and this is called screen doesn't mean they're the same thing. this, although this is going to pass this variable through to the draw method, I'm just calling it screen for now. We could call it scream if we wanted to, and it would do the same thing. As long as everything on the inside of here is referenced as scream, when we call this method and we supply the screen to this variable, this will carry the screen through to everything that's called scream here, if that makes sense. So I'm just going to set that to screen here. Okay, so now let's start adding variables in here. So an important thing that we're going to need is the graphic. So we can just go ahead and we can either put that directly in here, or we can add that as a variable. In fact, we're going to want to be able to control the position as well. So we're going to need an X coordinate and a Y coordinate, and we may as well just throw the image in here as well. That way we can get in practice for making other classes where we're going to be changing the image. And so once we have these variables here, we need to transfer them into a self variable. And what I mean by that is when we instantiate the ship, we're going to say spaceship equals ship. Why am I explaining it to you like that? We will do like spaceship. Spaceship. Yeah. And then we're going to do ship. And then see how it's asking us for the X coordinate, the Y coordinate, and the image. We could say we want to put this in the middle of the screen. And of course, we can get the middle of the screen on the X by calling our width. And then we can divide that by 2. And in the case of numbers that you want to that are odd that you want to divide by 2, you can do this, which is an integer divide. We get an integer divide by 2, which means if you get 3 and you divide that by 2, you're going to get 1.5. But because it's an integer divide, it's just going to be 1, because it's going to strip off the decimal. So that's our X coordinate, but then we want to do the same thing for the height. So then we want to do height, and the same thing, integer divide by 2. And that will get us in the middle. And of course, the last thing that we want to do is the image, which we would then supply the spaceship surface. Because we've loaded this graphic into the spaceship surface. This is a surface object. And then we're going to give the surface object into the instance of this class. And then anything that we do with image here is going to carry that surface with it. So right now, we want to basically convert all of these things into self objects so that they can be used between the methods. And so you can get away with just doing this up here. We can do self.x equals x. We can also do self.y equals y. So in this one line, we've got the first and the second thing being made assigned these two things. And then we want to do the same thing with the image. So we do self equals image. And now we have created a very basic constructor for the ship class. Also, in Foresight, we kind of want to set a speed for the ship as well. And we'll give it a speed of, say, 100. That's arbitrary. You can set that for whatever you need. I will say, though, without using delta time, you're going to want this to be a very small number, because for every frame, if you're moving at 60 frames a second and you set the speed to 1, then you're going to move 1 pixel every frame, which means you're going to move 60 pixels per second. But if we want to do frame rate independence using delta time, which I will explain when we get to it, we are actually going to be multiplying that number by a smaller number, less than 1. So then you're going to want to increase this to, say, maybe 100. It's not exactly 100 times, the difference. It's like for you to do frame independence, you're going to be looking at like 0.016. So it's somewhere between what is that, 5%? I don't know. Math. Who's good at math? I mean, a lot of people are, aren't they? So not even going to go there. Okay. And now we'll run it. Still nothing on the screen, because we need to draw it. So here we go. There's our draw. Now, what we want to do with this is we want to reference our screen here. And now we want to blit screen.blit. I can't remember what blit stands for. I could look it up. I know basically blit is used with sprites, and that was used in consoles and stuff like that. They had hardware to handle sprites, and they had different conditions and stuff like that. So blit comes from that, I think. So we want to blit something onto the screen, and that first argument is going to be the object, the surface that we need to blit. So our surface came from here, and then we instantiated it and inserted it into our image placement here. Then we took the image and then we turned it into something that can be transferred between all things. It's now a self.image. So now we want to finish its journey, and that's where it lands. Now we want to also give it coordinates on the screen. So now we need to set the coordinates, and we need to do that in the same way as we did with the screen here. It's a tuple. And then we want to reference self.x by self.y. And so now if we start this, part of me thinks I'm going to have an error. Let's see. No, we just have nothing. So, yeah. And that is because even though I have made an instance of the ship, I haven't actually drawn it yet. Now, I've referenced these methods, but I actually haven't called them yet. So now we come down to our game loop here. And so let's split this up. We will call this section handle events. And let's make a section here, and we'll just call it update. And it's as simple as referencing our spaceship object here. Like, we only create it once, but we can reference it and play with it like lots of times. So when we want to do something, we want to oh, it's not called player. Spaceship dot update, and we don't actually have anything here other than self. You don't. Self is just so that they can do things between each other, so you don't actually have to include that here. But now, why do I keep pressing that now? Now this is our draw section. Okay, I don't like having that right up against there. I don't know why I do that. Anyway, so then we do the same thing. Spaceship dot draw, and now we need to give it a screen because it's asking us there because that's what we set up here. So screen is our screen here. And so now if we start it, we still get nothing. What did I do wrong? Give me a sec. Okay, that didn't take long. Yeah, one of the things I forgot to do was once we draw it, then we have to actually update the screen. Because if the screen doesn't get updated, it's like all this stuff goes on in the background. And then the very final thing you do is you flip. Like, well, you can do, yeah, we'll do a flip. So you do Pygame dot display dot flip. And what that does is it basically updates the entire screen at once. You can do Pygame display update if you want to update individual like sprites and stuff like that. But if you do a flip, it does the whole thing, and that's fine for us. So now we should see our ship on the screen. Amazing. So right here, an important thing to note is even though we have a graphic on the screen and it's at a position which we made, in the dead center of the screen, you're going to find that graphic is not in the dead center of the screen, but the top left corner of it is in the center of the screen. And we can demonstrate that by adding a point at that position so that we can see exactly where it is. And we can do that because while we're here, like screen blitz self x by self y, we can also do Pygame. We can make Pygame draw a circle for us. So draw circle, and it requires a surface to draw the circle onto, which we have as screen. Also, to prove a point, I'm going to change this to something else. We're going to make that main screen, just to prove a point. So main screen, because if I keep them spelled, the same, you're going to think they're the same object, but then they're technically not. It's like, you're the same person, but you change different buses when you go to work or different trains. So we're going to draw a circle on the main screen. The color is going to be, let's make this blue. Pygame has its own built-in colors as well. The center is going to be the self dot x dot y, and that's a tuple. And I believe, oh no, we need the radius. So we'll do a radius of 2. And let's see how that looks. And see, look, we have a blue circle in the top left corner of where we thought the ship was going to be. So we kind of want to put the ship up there because it makes things a lot easier, especially for drawing or setting the boundaries of hitboxes and things like that. And the way that we can do that is once we have our image made or our image copied into the constructor, we then can make another object and we can tell it to get the rectangle of the image, which is the perimeter. And then we have access to other coordinate methods within that surface so that we can set our actual coordinates to. and this will make sense in a sec here. So we'll do self dot image underscore rect. That's the rectangle, and that's going to be self dot image dot get rect. There's an obvious joke there. I'm not going to go for it. That's low hanging fruit. And we want to reference this in the center. Good worked. I had to do it. Sorry. And so that is going to be self.x by self.y. So now the this object is going to be the image, but now that the center is going to be made the main point, the origin point. So now we have to come down here because instead of blitting the no, I'm wrong. We still need to blit the image, but now the coordinates have been shifted. So when we set the center of the rectangle to the position of where we want the ship to be, everything gets shifted by the difference. So now instead of saying that, which self x dot self y, which is the top left corner of it, we now are able to just call self dot image underscore rect. And hopefully I am correct. And now I don't know if you can see it, but there is a blue dot in the center. You know what? Why not just do 10? See, look, now it is in the center. So now we have repositioned the craft there. And on top of that, we can also create like a hitbox for it. So in the draw section, not necessarily in the draw section, but we can just do it here anyway. We can self.hitbox equals, and it's going to be self.imageRect. And I'm starting to realize, why am I doing that? When now we do Pygame.draw.rectangle, and the surface is going to be, what did I call it? Main screen. The color is going to be, let's make that red. And now the rectangle value is going to be self.imageRect. And now we have a rectangle that's filled in. And I didn't really want to do that, so maybe I've done something wrong here. I believe the problem is I didn't give it a thickness. So let's do 2. And there we go. So now we have this radius around the ship, which we can use as a method of detecting whether we collided with something or not. But that's going to be for a future video. Right now, we want to see this thing move. So let's do something simple, like just making it move across the screen. So instead of us now instantiating it all in the middle, let's just start at 0. Because the screen coordinates start in the top left corner. All surfaces in Pygame start from the top left corner. And then going right is a positive, going left is a negative, going down is positive, and going up is negative. So we want to start all the way on the left-hand side of the screen. And then to update our position, we want to increment the x. So during the when this looping through, going through the loop, every time we hit the spaceship update method, because it's gonna start here, move down, then it's gonna hit that one, and then it's gonna do everything that's in here. So what we're gonna do is we're gonna say self.x, which is the position that we are using. Well, it's the variable we're using to hold the position of the x. And in Python, you can increment by just doing plus equals 1. And that's going to move it to the right 1 pixel every frame, which is going to be, let's start this on, where did I put the frame rate? That's down here. So let's go down to like 30 frames per second. That way it's not so fast. So now if we do this, oh, only the dot's moving. And that is because the dot is using self X and self Y instead of the rectangle. And the problem is nothing else is moving, because the only time that I take the self X and self Y and move it is in the constructor section when we initialized it. It never gets updated. So an easy fix to do that is copy that. And then we can either put it here or put it in the draw section, depending on your preference. It depends on when you want this to happen. So, yeah. Now if we do it, it will start moving. Now you're probably observant enough to realize it's leaving a trail. And so if we comment out this and this, and then we run it again, and the ship is leaving a trail still. Now it's doing that because we're not painting over where it used to be. So this surface is not getting redrawn. The surface that the ship is on, the surface which is screen, this surface is not getting drawn over and over and over again. Only the surface which carries the ship is being redrawn, which is pretty easy. We just have to fill the screen with black. That noise, that's my son's phone dying. I'm sure he's going to plug it in. Anyway, let's do that. So we want to reference the screen. Now, because we're not in the draw section here, you know, we're not calling it main screen. So if I was to do that here, so look, main screen does not work, but screen does. And then we want to fill, and because the background's black anyway, we will just fill it with black. And now everything is updating. But that's all well and good. But we want to control it. So the way we're going to do that is we're going to introduce a very basic key system. And we can make another method for that. And we can call that method movement. You can call these methods whatever you want. As long as you reference them by what you call them, you're golden. So if we can spell movement correctly, and then movement is only going to have the self object. I always put pass in there before I think about what I'm going to be putting in there. And so now we want to keep a track of the keyboard. and know when we've pressed a key or not. And there's multiple ways to do that. We've seen that down here. We got, if event type key down, but we're going to do it slightly different here because it has better results. I'm going to be upfront with you. I don't know why. I tried using this key down method, and I kind of wanted to do that, and I still need to explore this because I want something different to happen when you press the key down than when you lift the key up. But right now we're just going to make an object, and it doesn't have to be self because it's not really going to be used anywhere else outside of the movement method. So we're going to keys, and then we're going to pygame.key.get pressed, and that's a method, so we have to put those parentheses on there. And now, if keys and the index of Pygame K underscore W, which will be the up, you can like add other things in here as well. Say, or you can do if keys, keys. I can just feel people screaming at the screen when like there are errors. Like you're like, no. Anyway, so we can do that, or keys pygame.k underscore up. So that's the up arrow. So you can do that. So it's if the key is either W or up, then we want to do something. So if we're going up, we want to decrease our y coordinate. So self.y is minus equals, and then self.speed. Now, we don't have delta time put in just yet. So I'm going to go back to doing speed of 1. Because that's what we were doing here with the x. We were making the x coordinate go across the screen at 1 pixel per frame. So we're going to do the same thing with the y. And that's why we have this variable here called speed. So we can just change it once here, and it updates everywhere. So if the key is pressed, self.y is going to go up. And so at the same time, we're going to put the down. So if the key is S or down, then we're going to plus. Now remember why we're doing this, because the coordinate system starts from the top left at 0, 0. So if we're going in a down position on the screen, we are increasing the coordinates in the y direction. And then if we want to go up, we decrease in the y direction. So let's start this. And now we're slowly moving across the screen. Now if I push up or down, hang on. Ah. Doesn't work though, does it? And that's because we're not calling this movement method. Now we don't have to call it down here like we're calling the other. In fact, I'd prefer to just stick with the basics, the update, the draw, and then the flip. And then these events as well. But now we can call the movement in the update part. And we don't have to do anything. So now, whenever we call the update method down here, then it's going to call the movement method and then continue on. You don't have to do it this way. I like to make lots of methods as a way of organizing, as a way of turning things on and off when you want, or depending on whatever. But you can do it. You can do it however you want. And here we go. Now we're starting to move up by pressing the keys. Pressing S, I'm moving down. Pressing W, I'm moving up. Using the arrow keys, I'm moving up. And then moving down that way. And don't just take my word for it. Let's go ahead and print out the key. We don't want to do it there because we can't. So print keys. This could be a bad mistake. Yeah, look at that. Notice when I press something though, it changes. So yeah, that was that's showing all the keys. So just take my word for it that it's doing it. If I was more prepared, which I'm not, I'm actually just recording this on the fly. I'd be able to show you. Well, no, let's go ahead and do that. Okay, I skipped ahead a little bit. Now we're gonna do it again. And here you go. Let's move this up there. It's like W, S, up and down. So W, S, and then up, and then down. So yeah, now you know how to do keys. So we want to add the other two keys as well. So let's take this and copy that and just paste. So we'll do A and left. Now we want to do that to the X. Next there. D and right. And so now we want to take that off of there because we don't necessarily need that there anymore. So now, there we go. A painfully slow ship. Now, it's painfully slow now, but if we were to take off the frame rate, now we're traveling at 1,000 frames per second. And so, look, it's faster. It's a lot faster. And that's not good. I mean, it's good because it's better than slow, but we want this to be frame rate independent. So what are we going to do to get that? Well, this is where we introduce delta time. And that's going to have to come in a future video because this one is long enough already. I was planning on about 45 minutes and we're about there. So yeah, this is where we're at. Now we have a screen. Now we have something that we can start moving around on the screen. We have the beginnings of a game. I mean, if you gave this to somebody who was easily pleased, they would have a hell of a time with this. They were like, oh, look at it go. Look at it go. Woo! But anyway, thanks for sticking around for this long one. I'm planning on making them probably around about this length, maybe. I feel like if I did anything shorter, it's not really going to cover enough. And I like to make sure that I'm understood. So please let me know if you were able to understand what was going on. If you have any questions, go ahead, put them in the comments. If you like what you see, comment, subscribe, like, comment, subscribe, and yeah, like, comment, and subscribe. Bye.